Welcome back. This is another video under electric circuit concepts. In today's video, we have a concept problem. So using the law of current division, we want to find the current through each resistor. And those resistors are connected in parallel. And they told us that the current is I and the voltage is V. We see we have an expression for V. So the common voltage across each resistor is V, because resistors in parallel see the same voltage if it's connected across the same voltage source. So to determine the current through each resistor, we need an expression for V. So V is equal to I times R. Thus we need to find I, or an expression for I. And we might not have to, but let's look and see what happens. So the expression for V, I times R, so we see that the resistors are in parallel or connected across the voltage source. So the voltage source V can see a total resistance of R equivalent. So let's write that as R equivalent. And to get R equivalent, we have to combine our resistors in parallel. So the R equivalent for resistors in parallel is equal as the follow: R1 plus R2 plus dot dot dot, goes on and on. However, let's start from two resistors in parallel. So we can basically go ahead and say that 1 over RQ is equal to 1 over R1 plus 1 over R2. We can simplify that, or we can combine these two by R2 plus R1 times R2. Now, R equivalent, so if we flip both these, we then get R equivalent is equal to R1 times R2 plus R2 plus R1. So R1 times R2 all over R2 plus R1. And as you know, it doesn't matter how we add those, so I could just say R1 plus R2. So we can now combine 3 or more resistors in parallel, but at this time, we know we're going to combine 3 because we have 3 for this circuit. So to combine the 3, we can take a shortcut, and let's just go from scratch. So we're going to start from 1 over R equivalent, so that's 1 over R1 plus 1 over R2 plus 1 over R3. We find a common denominator. So that means for 1 over R1, the common denominator is going to be R1 times R2 times R3. So therefore, in this expression, we're going to omit R1 or remove R1 and then add R2, R3 plus, again, for the second, we omit R2. And if you notice that if you put this expression on the top, R2 goes away and we're left with R1 and R3. But never mind that concept or the idea of doing that. The only thing we're doing is, once we find the common denominator, to make this R1 into this common denominator, we multiply it by R2 over R3. So basically what we're doing is we multiplying this guy by R2 and R3, and we have to multiply the top as well. So in that case, and it's just basically, when you do that, it's basically, so let's just put it out here. So 1 over R2, you multiply that by R1, or you could basically just R3 You could basically not follow this method. So basically this is basically multiplying this guy by 1. So we can then go ahead and just say we omit R2, so we get R1, R3. If we omit R3, we get R1, R2. So that is 1 over R equivalent. So R equivalent P, R equivalent for parallel combination, we get the common denominator move at the top. And now we get R2. So again, how we write the sum of the multiplications between each resistor is that we bring this down 3 times. We sum this 3 times while omitting R1, R2, and R3. So basically what that means, if we omit R1, we then get R2, R3, plus if we omit R2, we get R1, R3, plus if we omit R3, we get R1, R2. Omit means remove, or don't pay attention to that. So that's R equivalent for the combination of the 3 resistors in parallel. So I like to write my equation like that to be easier on my eyes, or just, to enter in my calculator. So thus, we needed the expression for V if we're going to find I. So the expression for V is going to equal to V equals I times R equivalent. And the current through each resistor can be found using the parallel combination and the expression for Z. So this is our parallel combination and the expression for V. So parallel combination and expression for V. So I1 is equal to the voltage across I1 divided by the resistance of R1. However, though, resistors in parallel connected across a voltage source V, all resistors see the same voltage. So that means I2 is equal to V over R2. I3 is equal to V over R3. Let's just show I1. So I1 is now equal to V over R1. So here we have the expression for V. We're going to call that R equivalent P. So that means I times R, and that would be R equivalent P divided by R1. So for I2 and I3, we just change these and write I2 and R2. The current flowing into the branch are the network of parallel connected resistor, and the total resistance seen by the voltage source divided by the resistor that we want to find the current flowing through. So that simplifies to I multiplied R1, R2, R3. And as we said earlier, we omit each resistor. So that would be, we omit R1, so we get R2, R3, plus omit R2, so we get R1, R3, omit R3, so we get R1, R2. And that should be divided by R1. So the current through I1 is as follows. So to find the current through I2, we change this. The current through R2, we change R1 to R2. And if we want to find the current through R3, we change this to R3. So that's basically it for this problem. See you in the next one. Bye.